let me express the situation this way. So we have a wire that's 100 centimeters, which I'm going to cut in 2 pieces. Okay, so the first piece I'm going to call, I don't know, I'm going to cut it at a length of x, and the other piece, of course, will be 100 minus x. Okay, I'm going to use this x to bend the string into a circle. Okay, I'm going to use this 100 minus x to bend this string into a square. Okay, that's what I have. I want to find the length of each piece of wire so that the sum of the areas is at a minimum. So I want the smallest possible area. Okay, so I could either use everything up to make a circle, or everything up to use a square, or do a combination of the two to minimize the total area. Okay, so what's given to me here? I know that the circumference here is x, and I know that the circumference here is 100 minus x. Therefore, each side here is 100 minus x divided by 4. That's clear? Okay, and here I'm going to try to find the radius because I'm going to need it to find the area. Okay, so I know that 2 times pi times the radius has to equal to x. And therefore, the radius here is equal to x divided by 2 pi. Is this okay so far? Okay, let's go. So we want to minimize the area. And the area is what? So it's the area of the disk, which is pi r squared. So pi times the radius x over 2 pi squared plus the area of the square, which is side power 2. Okay, so this is what I want to minimize. Okay, let's simplify it a bit. So it's equal to pi times x2 over 4 pi 2 plus, and here I will have 10,000 over 16 minus 200x over 16 plus x2 over 16, and with x, what's the interval for x? What's the smallest value that x could take?
0.
0, and the biggest?
100.
100. Nice. Okay, so x being anything from 0 to 100. Okay. So let's find the derivative. So a prime equals, so I have to derive this here. So it's 2 pi x over 4 pi 2. This will disappear. Here I could simplify this if I divide by 4. Actually, yeah, I divide by, no, I could divide by 8. It's 25 over 2. So minus 25 over 2 times. No, I don't need to derive, so just 25 over 2. And then plus the derivative of this, which is 2x over 16. Okay, if I simplify, a prime is equal to, so x over 2 pi minus 25 over 2 plus x over 8. We're good? Okay, so when is it equal to 0? So a prime equals 0 would mean that x over 2 pi plus x over 8 minus, so equals 25 over 2. And if you find x,
Wait, sir,
Yeah.
from where do the 25 come?
this one here, this,
Yeah.
if you simplify 200 over 60,
Oh, okay.
okay? So if you isolate x here, you're going to get 25 over 2 divided by, so 1 over 2 pi plus 1 over 8. Okay, and if you calculate this, this gives you 44. Okay, so x is 44. So now we have to find the value of the area when x is 44, when x is 0, and when x is 100. So let's go. A of 0, A of 44, A of 100. So if you plug in 0 here, you will get 625. If you plug in 44 here, I already did the calculation, you're going to get 350.06. And if you plug in 100 here, you will get 795.77 centimeters squared. And so as you see, this is the minimum, which is what we wanted. Okay, so we need to cut the string like this, the answer. You should cut 44 for the circle. And so obviously 100 minus 44, which is 56, for the square. And that's the answer. It's the answer that you have up there. Any questions on this? Okay, let's do another one. This one we didn't do anymore. Okay, so what are the dimensions of a rectangle with the largest area that could be inscribed in a right triangle of height 4 and hypotenuse 5? Okay, so I have a right triangle. I want to be able to fit the maximum rectangle inside. So if I'm to represent the situation here, like this. Okay, so we have a right triangle. This is 90 degrees. And I would like to fit in a rectangle inside, which has the maximum area. So let's say here. Okay, so I want to maximize this area here. That's the question. Okay, what's given to me is that this side measures 4 and the hypotenuse measures 5. Okay, so I'm going to write it here in big, that this is 5 and that this side is 4. So obviously this is 3 if we do Pythagoras theorem. Okay. Okay. So I'm going to call this here x, and so this part will be what from here to here, of course, 3 minus x. And same idea, if I call this y, then this part from here to here will be 4 minus y. Okay, so far so good. Okay, so this of course is y, and this also is x. Okay, let's write down what we want to maximize. The area which is equal to xy. Okay. The only thing I need now is to be able to express y in terms of x so that the area is just in terms of x. Okay, so let's just notice one thing here. So let's call this A, B, C, and D, E, F. Okay, so obviously this angle here is equal to this angle, it's congruent. This is also 90 degrees, this is also 90 degrees. So I see that I have 1, 2, 3 similar triangles. Okay, I'm gonna write this down. So triangle EDB and triangle CFE and triangle ABC, right? They're all similar, okay, because of the angle-angle property. Okay, they all have 2 angles in common. This one and the 90 degrees. This one 90 degrees, this one 90 degrees. All 3 triangles. Good? Questions? Okay. So since they're similar, that means that the sides are proportional. And therefore, if I do, for example, this triangle, the small one here and the big one, I compare the sides. So x over 3 is the same thing as 4 minus y over 4. Okay, or I could do the same thing here. 3 minus x over 3 is the same thing as y over 4. I'll do this triangle. Okay, so 3 minus x over 3 is the same thing as y over 4. Okay, if I send the 4 up here, so we'll have 12 minus 4x over 3 equals y, and therefore y will be 4 minus 4/3 x. Questions?
Can you repeat why 3x over 3 is equal to y over 4?
3x, sorry, y? Oh, this here?
Yeah.
Okay, so because I'm comparing these 2 triangles. So this one here, okay, and the big one.
Okay.
So 3 minus x is this side divided by the big side, 3.
Yeah.
Is the same thing as this small side y over the big side 4.
Oh, okay.
Okay?
Mm.
And so now I could express A as x times y, which is this, 4 minus 4/3 x. Okay, and so A is 4x minus 4/3 x2. This is the area that I want to maximize, and x is what? From what to what? What's the smallest value of x?
Zero.
0, and the biggest?
3.
3. Okay, it cannot exceed 3, of course. X, the smallest could be 0, and the maximum could be 3. And in both cases, of course, the rectangle will be completely flat, and so the area will be 0. Okay, so let's go. That's where we have to now maximize this function over this interval. So that's something that we've done a lot. So A prime is going to be 4 minus 8x over 3. So A prime equals 0 would mean that 4 minus 8x over 3 equals 0. And that would mean if you solve, you get x equals 1.5. And if x is 1.5, you plug it back here, and you'll get x equals to y equals to 2. Oh, sorry, I have to move up. Okay, and now I'm going to check if this is actually a maximum or not. So it seems like it. So A of 0 is what? A of 1.5 is what? And A of 3 is what? So A of 0, you check. You plug in x is 0 here, you're going to get 0. If you plug in 3 here, you're going to get 0 as well. And if you plug in 1.5 here, you're going to get 3. Okay, and so this means that this is the maximum area. Okay, which occurs at a width of 1.5 and the length of 2. Is this okay? Okay, if we were to do the second derivative test, just like this, since we're here. Okay, so the second derivative test. So I'm going to find A prime prime. So remember, A prime is here. So A prime prime is just negative 8/3, which is negative. Since it's negative, then it's sad, concave down. And so as you see, it doesn't betray what we're doing. So we have a maximum here. Always, it's a maximum.